Alright guys, welcome to another science video by Johnny and Dr. Johnny IELTS, and this is a one-on-one lesson, and in this class I and my students and we are working on learning activity 4.3 for physics, measuring resistance. Alright, so can you read what is resistance then?
The circuit we have seen so far is simple circuit. There are many other components that can be
Incorporated.
incorporated into circuit beside load such as light bulb. In this activity, you're going to learn about resistance and how it is used in another kind of load called a resistor. Example of resistor. A resistor is used in circuit to control where the current flow, are often used in the more complicated circuits of application and electronic device. Let's start exploring resistance, which is a property of conductor. It is a measure of how much the conducting materials slow down the flow of electrons as they pass through it.
Of course, measure how much conducting materials slow down the electrons as they pass through it. So basically, it just resists the flow of electrons. Let's just make it simple like that. Resistance is the ability of a material to resist the flow of electrons through it. How much it slow down the flow of electrons as they pass through it. How much electrons it's how can I say prevented from going further. That's a resistance. Okay, you can continue.
There's a resistance of a
Material
increase. The speed of flow of the electron decreases, resulting in a drop in potential electrical energy. The electrons slow down because more energy is needed to push them through a conductor, which higher resistance than one with lower resistance.
Just imagine it like this. Do you play games? Do you play video games? Okay, just imagine it like a battle, like a war, a battle. So if you have a place with high resistance, it means the enemy is resisting you, your force to get through, right? So you have to commit more soldiers, more weapons, more airplanes, more tanks in order to advance, right? So the same thing happens here. The flow of electrons doesn't get through easily because the material resists the flow, isn't it? So that's why it needs more energy, more thing to push forward through a conductor with higher resistance than one with lower resistance. So the same situation, right? You understand my logic here?
Yeah.
Okay, it's like that.
Resistance can be measured using a multimeter with a dial set to resistance. The unit for resistance is the ohm, named for German scientist George Ohm.
George Ohm.
A symbol to represent ohm is the Greek letter omega. The following table summarizes the electrical unit you have learned so far. Current, amps, potential difference, volt, resistance, ohms. Variable affecting resistance. For variable, determine the amount of resistance in the wire thickness, diameter, length, temperature, and types of metal. Take a look at the detail of each one of these variables, then answer the question following in your notebook.
Question. Hmm.
Wire thickness. Thinner wire have more resistance because in order for the electron to pass through them, they have to pass single file since the space they are trying to pass through is limited. When this happens, electrons end up waiting in line, cause, causing a backup. If the wire has a larger diameter, the electrons have more room to move, and therefore the resistance is less. You can see example of this in some of the power cable for different applications in your home. If you ever look behind the stove or clothes, you see that their power cord have a much larger diameter than the power cord of our lamp. The stove and clothes dryer need a lot more energy to function than the lamp,
Hmm.
so they each have a cord with as little resistance as possible.
Because basically clothes dryer and stove, they heats up a lot, right? And that heat is provided by the large resistance they have. So as so as the thing, so basically the definition they say that if a material has more resistance, more energy is needed to push the electron through it, right?
Yeah,
So it means that if the material has more resistance, more energy is used, and more energy is used, it means more heat is produced. And clothes dryers and stove, they operate on heat, right?
yeah,
So of course they need like a lot more energy than a lamp or the equipment. So, but then their cord they need to be thinner to allow the electron to flow into the device themselves, right?
yeah.
You don't need even more resistance because the core they need to allow that much electricity to flow through into the device in the first place. So you don't need that extra like thickness to increase resistance, right?
Mm.
Because think about it, if you need like a lot of electricity already for the device to function, you don't need even more resistance. Because the more resistant, basically the more electricity you will have to use and the more money you have to spend. Get it? You understand it?
Yeah,
So basically, if you have a device that uses a lot of electricity, like a stove or a clothes dryer, their cord or their wire need to be thin with little resistance as possible to save money. And also one thing, if the wire is too big, it has a lot of resistance. It heats up. You remember what I said? If it has
yeah,
higher resistance, it takes more energy to pass the electron through it. So it heats up. You don't want the wire to heat up. It can melt. It can be dangerous. So that's why the cord need to be as thin, as little resistant as possible. Okay, I need to make sure. I need you to explain again to make sure you understand it. Can you do it?
yeah. I can.
All right, please. I'm all ears.
The more energy is needed
Hmm.
for electron to overcome the resistance.
Okay,
Stuff
longer
and drop.
wires and more resistant. Just imagine, it's like the army. Your electron is your soldiers. You don't want them to go a long way to the front. Don't want them to go a long way to fight the war. So longer wire, longer path, more resistant. Because the soldiers gonna get tired, right?
Yeah,
Think about it. So longer wires, more resistant. Because the longer pathway, the more energy is needed for electron to overcome the resistance. So of course, the longer the way, the more enemy you have to fight. Just imagine it like that. So the more resistant. Same thing to electron. The longer it is, the more material it is that the electron has to flow through, the more the resistant. Okay, let's continue.
Yeah. So they have a very short power core to ensure no power is lost to resistance. As a result, less potential electrical energy is used for transporting the current to the stove and wood fire.
That's why stove and dryer, the cord is so short. I don't like it at all. Because you have to plug them into extension cord. It's the same thing. I thought that maybe they want to save up, what's it called? Wire length. They don't want to have long wires because of other reason, but now I know. Very short power cords to ensure no power is lost to resistance. But then you have to plug it into extension cord anyway because it's far from your electric sockets. Yeah.
In contrast, the power cord for a lamp can be long because the loss of energy to resistance is not as important. Convenience of a long cord outweigh any problem with the small loss of power. Temperature. As the temperature of the metal conductor increases, so does its resistance. When the wire is cold, the electron can flow evenly and quickly. When the wire is hot, the electrons scatter and bump into other particles that slow them down. When temperatures are very low, most conductors work better. New recently discovered material called superconductor make use of this. Superconductors are able to conduct electricity with almost no resistance. They tend to operate at extremely low temperature, usually cooled by liquid nitrogen.
Mhm.
Types of metal. This list shows the resistance of common metal ranked from least to most resistant. Copper, a common conductor, is second on the list, indicating that its conductivity is high and its resistance low. It is sometimes beneficial to use different types of metal with higher resistance in wire because it will heat up more quickly. For example, an electric room heater uses resistance to beat up its wire coil, creating warmth.
We use
Do you
copper
know
a
that?
lot. We use copper a lot because copper is actually relatively cheaper. The first in on the list is silver, but it's so expensive. Nobody use silver for wire these days. It's so expensive. But copper is like okay, the price okay. The resistance is low, conductivity is high. Can you just read it? Yeah.
Yeah. So, so copper is like the price is like it's
Did
not
you
very
say something?
expensive, right? Copper price is not like very it's not
Okay,
very
okay. Why is
expensive.
your voice like lower now?
So, wait, what? So it's like the copper price is like not very expensive, right?
It is a valuable resource, yes, but it's not that much expensive like silver. Silver can be 4, 5 times, or even 10 times more expensive than copper. So just for that little bit increase in conductance, and you have to pay that much more money? No, it doesn't make sense. So that's why people use copper. They don't use gold for conducting much, of course, because of the same reason. It's too expensive. But you know where
Yeah.
gold is used?
Where?
Electronic in electronic boards, electronics inside your laptop, electronics inside of your iPad, for example. A lot of them are gold plated because it increases conductance. Headphones, the wire of headphones sometimes is gold plated too to increase conductance, and it doesn't oxidize easily. It doesn't become it doesn't react with oxygen in the air, so it remains shiny and conducting electricity quite well. But of course, these things are expensive, so people don't use it too much. Just gold plate, not like the whole thing is gold. Okay, and then tin, tungsten, aluminum. Sometimes we need that resistance because that resistance produces the heat. So that's why we use them in clothes dryer, for example, hair dryer, heaters. What else? Stove, microwave. No, it's a stove. What is the thing called? The thing you put the bread in there and then it heats up the bread. What's it called? I forgot the name for
Yeah.
that device. Bread maker? No. Alright, anyway,
Egg
please
maker?
continue.
Variable affecting resistance.
Why are the
Why
metals not
are
very thick?
filament
Okay, you
and
know the
light bulb?
answer. Please answer that. Okay, did you successfully got the answer?
Yeah.
Why isn't silver used in wire copper is? Because it's more
Expensive.
expensive, much more expensive. Even though the
Yeah.
resistance is lower than a copper, but it's too expensive to use.
Yeah. It said
Just
here
read
that.
the answer. Expensive jewelry, and other artifacts. Too expensive to use in wires.
Ah,
The cost is more cost effective. That's the problem. That's the thing. More cost effective.
cost effective.
Like for that little increase in conductance and that much increase in price, it's not feasible. It's not a viable option. It's not cost effective. So that's why we use copper instead of silver. It's more cost effective that way.
Resistor. Resistance can be used to control the flow of electron through a circuit using a small device called a resistor. A resistor restricts or resists the flow of current and lower the voltage or potential as the current passes through it. What is the result of creating more resistance? Electrical energy is converted into heat. Resistors are usually used to maintain a safe current within an electron device or application. The flung symbol is used for the resistor in the circuit diagram.
Okay, circuit reconstruction tools. Remember that thing that you burned stuff?
Yeah.
Circuit construction tools. Ohm Law.
Yeah.
So the light just shines. Of course, it eats up some electricity. So, this is a traditional light bulb. In a traditional light bulbs, 95% of the electricity is turned into unuseful heat. So basically useless heat. 95% is turned to heat. Just 5% is turned into light, which is exactly what we want the light for. So you see, light bulbs like this, traditional light bulbs, are great for winter time if you want to heat up your home and have some light. So light bulbs is actually a resistant because it eats up a lot of electricity in there, right? And it
Yeah.
it produces a lot of a lot of heat, so it's a kind of resistant. It has resistance, yeah.
Mm.
Someone calls.
Ohm are
Say again?
related to each other.
You're talking about Ohm
Uh,
Law, did you?
yeah, Ohm law.
Now that you understood the basics of the resistance, let's explore how it relates to voltage and current. Of course, they are related in the formula. The formula that explains how potential difference of voltage V, current is ampere, amp or I, and resistance is ohm, R, are related to each other in a circuit called Ohm law. So V equal to IR, voltage equal to current times resistance. Or you can rearrange this formula in a way. Can you go down, please? You can rearrange this formula so R will be equal to V divided by I, right?
Yeah. Wait. V. Investigating Ohm law activity. Using the simulation below, explore and change the value V and R to see what happened to the current I. Answer the question that follows.
Okay, so what happens here is that, okay, so you have a thing you need to play with a bit to see if you have big V, small I, or something like that, how they are related to each other. Let's play a bit with this. Okay, so let's have um, big R and big V. So of
R and big.
course, according to the function, according to the formula, I has to be very small. If you decrease the voltage, something else will have to decrease too, which is the I.
VI.
So they are, how can I say, they change in the same direction. So basically, it's what's the word to use? Proportional. They are proportional to each other. V and I are proportional to each other because the bigger the potential difference, the bigger the current will flow through something. So V and I are proportional.
No.
You can see there, V and I are proportional. But if you play around a bit, you will see that I and R are anti-proportional or anti-proportional to each other. So just imagine if you have too much resistance, then the current will be very small. It cannot pass through very well, and vice versa, the other way around. Just play with it a bit. You will see.
Increase the value of our ability to be the same.
What happens when you increase the value of V but leave R the same? What do you think? If R is the same and you increase V, of course I will increase, right?
Yeah, I will increase.
So the current will increase. The current will increase.
Will increase. Once you're done the question, check out this extension activity to learn more about how scientists figure out Ohm's laws.
Okay, let's continue. You read it, please.
Oh yeah, sorry.
Manipulating Ohm's law.
Ohm's law is V equal I times R, which is very helpful if you need to calculate V. Then you can multiply I and R to find V.
Mm-hmm.
What if you need to find I though, or R, using algebra? You can rearrange the Ohm's law formula to make it easier to find I and R.
Of course, if V equal to I times R, so I will be equal to, you move R to the left side, right?
Yeah?
So V divided by R. I equal to VB divided by R. So if you want to find R, you move I to the left side, so R will become V divided by I. Just like that. Easy, right? Algebra, you learned it already.
Yeah.
Now let's proceed to analyze how to solve problem using Ohm's law. All right, it's not many things to look at that now.
Problem solving method. Grasp. You're about to learn a problem solving method that helps you organize your thought logically and help you choose the correct equation. Grasp method. This problem solving method is known as grasp or sometimes graphs.
Mm-hmm.
The word grasp helps you remember the sequence of steps in this process.
Mm-hmm.
Given, require, analyze,
Analysis.
solve. Analysis.
So
Solve.
statement
Statement.
or paraphrase. Okay, let's read it. What is grass?
List the given quantity outlined in the problem along with their unit. Identify the required quantity you are trying to calculate and what equation you would need to use. Rearrange if necessary. Substitute the given value into an equation, including unit. Calculate the answer and include unit. Write a final summary statement related to the information in the problem. Let's proceed how to the solution of this related problem using grasp method.
Can't believe it. Today it's like Thursday
Um,
already, huh?
yeah, Thursday.
Oh, time passed by in the blink of an eye.
Simple problem.
Mm-hmm.
A 12V battery power the headlight of a car. What's the resistance of the headlight if they draw
3 ampere of
0?
current when turned on.
Answer show how to use the grasp method and explain what's happening at each step. Write down that you are giving, in this case, you are told that V equal 12V and that I equal 3.0A.
Mm-hmm.
What problem are you
Being asked
giving
to solve.
being asked to solve? What equations you require? In this case, you are asked to find R. Given V and I, therefore you use the equation R equal V divided by I.
Mm-hmm.
Form your analysis.
Analysis.
Substitute.
Analysis. The stress
Analysis.
is on the second syllable. Analysis. Analysis. Analysis.
Analysis. Analysis.
Analysis.
Analysis.
Mhm.
Substitute the known quantity and their unit. R equal to volt divided by 3 point amps.
Okay, so you get R equal to 4 ohm.
Ohm.
And remember, you have to put the proper units there. Always remember to put units, okay? So 12 volt divided by 3.0 ampere. So R equal to 4.0 ohm. You have to write everything down like that. Otherwise, it doesn't have any meaning. Remember, numbers doesn't mean any meaning. It doesn't have any meaning in physics, unless you go with a unit. For chemistry, is the same thing. For biology, same thing. Maybe in math, numbers has a lot of meaning, but in other sciences, not really. You have to go together with units.
Write your summary statement giving the answer to the problem. In this case, you might say the following. The resistance of the headlight is 4.0 ohms. I take a quick break.
Say again?
Can I take a quick break?
Sure.
Power rating. Now you may be wondering why when you purchase a household electrical device or appliance, the label doesn't tell you the resistance of the device. Instead, another quantity called power rating, or simply power, P, is listed. Power measures how fast the electrical energy is transferred, converted, or used by the device or applicants, and it's measured in watts. This is an important quantity to consider when choosing energy-efficient application
So power just
for
means
your
like
home.
simply if your device is strong enough or not. Strong or not strong. But it also means that how much electricity your device uses. For example, if something has a higher power than the others, then it will use a lot more electricity than the other device. For example, electric kettle is like 1000 to 1200 watt, compared to a light bulb is only like 40 to 100 watt. What does that mean? You know what that means?
Not sure.
It means electric kettle at a 1000 to 1200 watts, it consumes a lot more energy than a light bulb. So power basically means like how much energy your device consume, how much electricity your device consume, and also equal to how much money you have to pay.
This information helped me look at the most energy efficient model. Look at the example of an inner guide label. You can see that this refrigerator used 300 watts, which is on the lower spectrum of energy consumption of similar application. Let's sum up the application in your home. What power rating is listed on their inner guide label?
Mhm. Let me just read the French words here. Consomme le monde d'énergie. This sounds so fancy. Numéro du modèle. Number of the model. Modèle similare comparé. Similar model compared. Sooner or later you have to learn French if you want to go to Canada. No, maybe just Quebec, like Quebec region.
Yeah, I know that.
Uh-huh.
Loads and power rating. Take a moment to consider how power is calculated. Calculating power using two quantity, your study, current and potential difference.
So
So it's
E
the
equal
same
to
thing.
I times V.
Oh, the problem, the crash method can be solved related to microwave oven draw 10.5 A upon current V household. What is its power rating? Power rating. So we be
You have to calculate the power rating of that according to Grass method.
power rating.
Yeah, what do you think?
Ooh, microwave. So it should be I think it should be 10.5 multiplied by 110 should be 1,155. I think that's the power rating. Yeah. Power rating of the microwave oven is 155. This may be rounded up and labeled as 1,200 W on the packaging. Usually goes. Aircraft flow provides an to flow of electron in circuit by converting an electrical energy into a type of energy, heat, light, or motion. And how the sun vary depends on the metal used, the conductor, and its length.
Mm-hmm. It's on load, right?
Yeah,
So load can include any equipment that uses that electricity. For example, light. It converts the energy of of electricity into light. If it's a stove or a tumble dryer or a hair dryer or a heater, or radiator, convert that electrical energy into heat. And if it's like exercise machine, for example, like treadmill, it converted electricity into motion, or blender in the kitchen, same motion. So
yeah.
basically, load is just the thing that uses up the electricity. It convert the electrical energy into either heat, light, or motion. Mhm.
Potentially different uses. And that's like it too. Moving on to
Hmm. Now you talk about renewable energy versus non-renewable energy sources. Hmm. Some energy is renewable, which means they can be made anew. It won't run out. But some energy is like you have to be careful because eventually it will run out and you will not be able to use again. Like for example, fossil fuel. You cannot just keep taking the oil or coal from the ground and expect to last forever, right?
Yeah.
You just can't. So that's why we have to depend on like new energy sources, such as solar energy, wind energy, hydroelectric hydroelectric power. Hydro means water. You know the dam, right? Water dam.
Yeah, damn.
It uses the flow of electricity, flow of water to operate these turbines inside of that dam and to produce electricity. So these are renewable because you can make new. It won't run out. It won't run out. But fossil fuel are non-renewable because it will eventually run out. Okay, just read that now, please.
Yeah.
Hmm.
Renewable versus non-renewable energy source. Now that you have a better understanding of the basic energy and electric current, let's explore how energy is produced and its associated costs and benefit. In Canada, we have solid infrastructure that support electricity production, and so major power failure are rare. A big one that has affected many people in Ontario happened in August of 2003 and lasted for over 5 hours, much longer for some residents.
Hmm. So in the same country, different areas are
Yeah,
connected in something called a national grid. A grid
national
or
grid.
national grid. So in case of a terrorist attack, it can affect the whole nation, like blackout, no electricity.
Oh,
Hmm.
it involved part of
You
the
need a grid.
electrical
You need a grid
production.
because some region of a country may be able to produce electricity, but the other region will not. So that's why you need a grid so that everyone receive the same amount of energy, right?
Yeah,
So, but the problem with the grid is that it affects the whole country in case there's something happen, so it's not perfect. Never meant to be perfect, no.
yeah. Function distributions over the wide area of North America, demonstrating that these systems are interconnected throughout North America by something called grid. It's affecting an estimated 10 million people in Ontario employing 5 million people in 8 US states. There are many debates about how the energy to power this massive grid in North America is produced. There are many objects to support moving away from non-renewable energy source, one that run out to renewable source. So many debates about how the energy to power this massive grid in North America is produced. There are many projects to support moving away from non-renewable energy sources. Identify some non-renewable sources that you know. Fossil fuel, such as oil, natural gas, etc. Nuclear power, coal. High hydroelectricity, solar power, wind power, biomass. Energy production. To understand how electricity is distributed to consumer, select one of the following resources. Most take up electricity for a generator, convert energy from another source into electricity. They all rely on spinning a large wheel of copper inside a strong magnetic field to rate the flow of electrons. First major electric power station was Niagara Falls.
We're talking about turbines now. So basically, there's a lot of devices that use turbine to create electricity. For example, a dam. The picture of the dam you see down there, it's actually a hydroelectric dam. And the flow of electricity will cause the turbine to swing. As the turbine swing, due to something called induction. Induction. It's a phenomenon that will help the turbine and the generator to produce the electricity. So basically, it converts the flow of water into electricity through the generator and turbines. So this same thing happens in wind energy, in wave energy, because these things convert the flow of wind, the flow of the waves of water to electricity using turbines and generator.
Hmm.
Okay, please read that.
Turbine was attached by a shaft to a generator, composed of coil of copper, wire that was spun inside a ring magnet. As the water spun the wheel, the copper coil inside the generator rubbed rapidly against the magnetic field, causing electron to flow. The flowing electron were converted to AC before being sent to the grid. Since falling water was the first way of generating electricity, was known as hydro, the Greek word for water, electricity. Even today, people use the word hydro for electricity, although other methods are used to generate electricity. Consider the different parts involved in the electricity, the production and distribution. Are you able to match each part with its explanation? Non-renewable energy source. Now that you have an understanding of how energy is produced, let's explore where energy is coming from. Non-renewable energy sources are energy sources that can be used only once. When they are used up, it can take a long time to create new energy store. Non-renewable energy sources burn easily, but are harmful to the environment.
Of course, because fossil
Example.
fuel, when they burn, they produce a lot of CO2, which is a pollutant, and harmful to the environment, of course. It's very harmful, and it stays in the atmosphere for some time and then causes a lot of pollution. Coal burning, natural gas. And nuclear power also is dangerous because nuclear power, even though it produces a lot of electricity, but you need to understand that there's a nuclear waste as well. You need some water. You need water to cool down the reactor inside a nuclear power plant. Otherwise, the reaction will go too fast and uncontrollable. It will become like a nuclear bomb.
Well, that's
So that's
intense.
why, okay, we can control the speed of the nuclear reaction by cooling it down with water. But the problem is, after it cooled down, it becomes irradiated. So it becomes radiated water, wastewater, very toxic, highly radioactive. And that water you have to store in containers. You have to store in like this kind of metal container, and it takes like I think it might take thousands of years for the water to become normal again. And you cannot just throw that water away. You have to store them inside of like you know mountain storage areas, well guarded. Because if it gets out, it might pollute the environment so badly that nothing could live for decades, maybe hundreds of years.
And
So
years.
that's why nuclear power basically is very dangerous too. Literally nothing could live.
These courses, such as geography, you may already know a lot about non-renewable energy sources. If you'd like to review the pros and cons of using coal, natural gas, and nuclear power, read the following summary. Renewable energy source. Renewable energy sources are becoming more important in Ontario as the province tries to less on non-renewable fossil fuel.
Mm-hmm.
There are four main types: hydro, water power, biomass, solar, and wind.
Mm-hmm.
Each has its own cost and benefit. Example of renewable energy source at hydroelectric, biomass, and
And
solar
solar
power.
power. That's what I was talking about. These things are renewable because they can be made and they can be made anew again. They are natural. It's almost limitless. While fossil fuel, even though it's extremely efficient in terms of energy, but it will run out soon. It's non-renewable. Oh, by the way, so I told you next Monday I'm not available. So can we study on Wednesday? Next Wednesday, I mean. Wednesday the 19th.
Yeah, sure.
I freed up some spots already, so. So, oh wait. So, 19. Okay, please write down Wednesday the 19th we have class.
Wednesday 19.
Uh huh.
Yep, done.
Okay, good now.
In peace. At the end of the lesson, in this lesson, you will be writing on a energy source. First, we will work through some important skills that are required when writing PCBs. Expression and opinion. There are a number of issues involved in generating electricity in Ontario. Most are related to political, economic, environmental, and health factor. Learning how to express your opinion on such matter is very important. Many people do this by creating their own blog, reading online, comments on news story. It may be important to you that particular person know your own opinion. One of the best way to do this is through a letter to the editor of your local newspaper or to comment or to a particular government official, such as your mayor or municipal councillor, your member of provincial parliament, MPP, You're a federal member parliament MP.
Member of
You will
Parliament.
have, yeah, you will have an opportunity to practice writing letter and using argument to support your opinion. Supporting argument must be factual, clearly explained, related directly to your opinion, supported using more than one point. Typically, a full answer to an opinion question requires 3 to 5 pieces of support. You want the audience to take your opinion seriously, so you need to follow the rules required. You might even complete a cost-benefit analysis before writing your letter. Example: oil extraction in Alberta oil sand. It was used as an example throughout the course. I think we should not create a wind farm near the oil sand so that it can power equipment used up there. I think we should not install a hydro dam near the oil sand. That I do not. Evaporation is environmental. Soil explosion due to deforestation in Hadley.
Warning, fish contaminated, do not eat, because basically these fish are poison. They are contaminated with like heavy metals from human activity, especially mercury poisoning by industrial processes. Industrial processes, they produce a lot of they uses a lot of toxic things, and then the wastewater, of course, being released to the environment, and of course the animals, they fish, they eat it, and then we eat them. It's terrible. Okay, these are all the topics that you can write about.
Yeah.
These are topic about environment and how to protect it. I think we should spend some time on it. I mean, on you on your own then.
Yeah.
This is near the end of it anyway. So producing energy that's it. I think.
Yeah, that is
I think that's it.
basically
Okay.
it.
All right. I'll see you tomorrow then. We continue maybe 4.5, isn't it?
Yeah, 4.5.
Okay. Just don't forget these parts that you had to work on your own. Okay.
Yeah.
All right.
I know.
See you then. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh đó, để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.